Welcome. My name's Michelle Odwin, and I'm going to be presenting the second part of my presentation on transdisciplinarity. This is an introduction and overview. In the first part, I presented the principles around transdisciplinarity, the concept, and its location within the field of sustainability science. In this presentation, I'm going to speak more about the process, certainly the process that we'll be following in this research. There are many different processes that can be followed for transdisciplinary research, but we're going to look at the one that we'll be following in this research. It is one that needs to be adapted to your circumstances and also as the research progresses to changing conditions as the research evolves. But there are some very key and core elements to any transdisciplinary research, perhaps the most important being joint problem definition. But we're going to start from the top on developing the initial concept of the social ecological system. So if we look at what this means, before we go to the slide, if you just think of the social ecological system being mapped out like a mind map. So you have various elements, social elements related to governance, institutions, and then the ecological elements of the landscape, as well as economic. So GDP, local economic initiatives, and so on. And kind of a mind map where there are linkages between these various elements. So that is one way of depicting the social ecological system, or the environment as a system, with the connections between the social, economic, and environmental. Now we're going to look in this course at causal loop diagrams, which is like a more sophisticated mind map. Not that much more sophisticated, it's very much like a mind map, and we'll be looking later at how these can be constructed. But there's various ways of developing an idea of the social ecological system. Such mind maps are one way, the others are narrative. Then of course you have spatial mapping that can show the location of the system, computer models, and so on. And what is best is probably a combination of various tools in depicting the social ecological system. But perhaps more importantly is, why should we be developing this concept? And one of the reasons is that if you think of a puzzle in a box, and the picture of the puzzle that you're drawing is usually on the outside of the box. Now, our concept of the social ecological system is that picture, so that when you get the different puzzle pieces, you know what you're working towards. So this initial concept, of course, as research progresses, the initial concept or the initial picture on the front of the box can become more nuanced, it can get more detail. But the initial concept is what is going to guide the different disciplines with their different pieces of the puzzle on how they're going to link together when we do the research. What are the important relationships that need to be considered? So you can think of that as a metaphor for the social ecological system. I previously worked in the field of environmental assessment and management, and often we would have different specialists coming together. They would have their various specialist studies, and I would be in the position of needing to integrate these. And what occurred to me is that they're all working from a different idea of what the key elements in the system are. And that's problematic when you're trying to integrate. And the issue is that there are an infinite number of elements in the system, and all these elements are connected to an infinite number of other elements. So in order to enable knowledge, we need to identify what are those features of the environment, of the economy, of society that we're going to consider in this research. And you have an initial idea that gets refined as the research progresses. But we need to start off with a shared understanding of what those are. Now, one of the key activities in defining the social ecological system is actually delineating the boundary. Now, the spatial boundary might be determined by a range of different factors that are a combination of more objective elements such as municipal boundaries or catchment areas, But it also involves a number of subjective elements, so considerations of expediency, what resources are available, how much time is available, and so on. Now, that doesn't only apply to the spatial boundary, it also applies to the boundary of what elements do we consider. So those more subjective questions around how much time, how much resources, what skills do we have, it influences those elements as well. So the important thing is to delineate that boundary and to make it explicit. And drawing this social ecological system makes explicit what elements we're going to consider, where the boundary of this study is going to be, not only spatially, but in terms of the issues or elements that are going to be considered. So it, number one, helps with identifying the important linkages, and number two, with what elements of a system we're going to consider, given that complexity theory tells us that all elements are connected to a vast array of other elements. Everything is connected to one another. So in order to enable knowledge, we need to draw these boundaries. Issues to be considered, spatial area to be considered. If we didn't draw these boundaries, our kind of model of the system, or if we tried to understand everything in all of its complexity, all the elements and everything that they're linked to, then our knowledge of the system would be, or our model of the system would be as complicated as the system itself. So in order to enable knowledge, we do need to do an element of reduction. We do need to say, these are the important elements that we're going to consider, and this is the boundary. And that's based on an argument that was developed by Paul Selliers, who studied complexity theory. And I would highly recommend his work if you're interested in systems and complexity. So the bottom line here is that we need an initial concept of the system we're considering. That is not only the spatial boundaries, but also the social, economic, and ecological elements and the linkages between these. This assists in integration between the disciplines. It enables dialogue between stakeholders because we're all looking at the same thing. We're all looking at the same version of the system that we're debating from. It helps the research focus on key linkages. There are a number of tools that we can use, as I mentioned earlier. And very importantly, in the last point, there is no single, final, correct description of what the social ecological system looks like. That is because we have to make choices. That is because we cannot describe the system in all its complexity, with all its elements comprehensively. We have to select. And so there's no one final correct description. And because of that, we need to be explicit and transparent about, well, where did we draw the spatial boundaries? What issues are going to be considered? And why are those issues considered important? And so on. So more about that later when we discuss causal loop diagrams. So the next stage is the development of the vision, and this of course needs to involve stakeholder engagement. I'm sure many of you have been involved in visioning processes and often have felt perhaps that they're very broad and not necessarily that meaningful. But I think visions can be meaningful if they reflect the values of the community that you're engaging with. So the vision statement should be a value-based statement. Sure, it's informed by scientific knowledge, but it is a value-based statement. One person who I was asking about vision statements said to me that he thinks that the vision should reflect the character of a community. If you read the vision, it should reflect the character of the area, and I think that's very true. So this is an example of a vision. We did a rural water supply project, and we had numerous case studies. I'm going to mention another one just now. We had 3 case studies. This was one of them in the Northern Cape in South Africa. This is a very dry area, very sparsely populated, and agriculture is one of the primary activities. And the vision in this area, which is called Kamiesberg, is that Kamiesberg wants to improve the quality of life of its people through the sustainable, cost-effective and integrated planning, management, development and protection of water sources, water usage, water supply and distribution. So there are a number of value words here. Sustainable, cost-effective is a value, integrated is a value, quality of life, of course, is a value. So these are these reflect what the community find important. And this project was around water supply. So the vision is within the context of water supply. And I think that that is not a problem. It doesn't need to relate to all aspects of development if you have a particular focus within the research, like this one on water. So the vision can also be articulated as objectives, and in the same project with rural water supply, we're also working in the Eastern Cape. This is in Bulangula, and that's a Bulangula River you see on the bottom, an estuary, and this area does not have piped water or sanitation, and we were looking at what are various alternative means of improving their water supply. And there are two objectives that we derived from comments that came from the community workshops. And the first was improve the quality of the water in order to reduce disease in the village. Disease, particularly diarrhea from poor water quality, is very prevalent in the area. And the second objective is improve household access to water supply. There's a very high seasonal variation in water supply, and also many households have to walk very far down to the river to get water. So they didn't have a single vision statement, but they had these two overarching objectives that they wanted to achieve. But those represent the kind of vision where they want to go. So the next stage is the development of the research questions. And what I'm going to say here is just the general logic behind developing the research questions. And this is, when we say joint problem formulation, it's joint, in this context, it's joint research question development. And you'll see why this is joint, because if you have a look at the process that is used, it starts with, we have an understanding of how things are now. And that's our description of the social ecological system. It's a description of the environment as a system. How is it now? Then we have how things would like to be in the future. That's the vision and objectives and or objectives. So that is what have stakeholders said is their desired future state. That's value-based knowledge. That first one, how are things now, that is system knowledge. You will remember in my previous presentation, we spoke about three types of knowledge in transdisciplinary process: systems knowledge, target knowledge, and transformational knowledge. Systems knowledge, how things are now; target knowledge, how we would like them to be; and transformational knowledge is what action we're going to take. But before we can get to the action, we have what are the questions that need to be answered to move us from where we are now to where we would like to be. Another way of phrasing that is, what knowledge is required to move us from where the system is now to where we would like them to be? And that, the answer to that question, what knowledge is required, that becomes the research, and that guides the research. And we break that down into questions that need to be answered. So you can see it's joint problem or joint research question development because stakeholders have been involved in defining, well, how would we want the system to look in the future? And ideally, stakeholders should also be involved in describing how things are now. And then also the research questions that are developed can be circulated for comment amongst the stakeholders. So here's some examples in that Eastern Cape case that I spoke about earlier. One of the objectives was to improve the quality of the water in order to reduce disease in the village. So some questions that were developed there is it possible to treat the existing river, borehole and spring water to improve its quality? Our system knowledge had told us that the quality was poor, and now we need to find out, can we treat it? Technological knowledge that the team had told us that there were these tulip filters that could possibly be useful in filtering the water and making it usable for domestic, for drinking purposes. So we didn't just come, well, here's a solution, here you go, these water filters can solve the problem. In transdisciplinary research, we need to know, in this specific context, what works, what doesn't work. So it's turned into a research question. How effective are these tulip filters in removing E. coli and other bacteria in the long term? And how will the change in filters be managed? So that question relates to, well, how can we maintain the use of the filters in this area? Are they appropriate to this area? And what happens when you need to change them? And so on. So that was more conducted like an experiment. It's not coming with a solution. It's saying, we have this technological knowledge that these filters exist. Now let's find out, in this context, is it going to be useful? And do the community, do they find these water filters useful? Do they find it something that can address their water quality issues? And the second question is it possible to cost-effectively remove the magnesium and iron? The water had borehole water had a lot of magnesium and iron in it. So is it possible to remove this, and for that then to become a significant source of water for the community? So there was a whole lot of information that was required for that second question around costs, most certainly, and whether those costs made it possible or not to remove the magnesium and iron. So another example from the second objective in the Eastern Cape was improve household access to water supply. I mentioned earlier that communities that there are seasonal changes in water supply in this area. And so one of the questions was, how can the communities improve their ability to adapt to the seasonal changes in water supply? And firstly, we need to know more about what these seasonal variations are. And then what does the community do at the moment? The farmers, for example, how do they adapt to these seasonal changes? So we would need knowledge from the farmers. We need information from them. And the third is, based on discussions with the community, not merely what the research team thinks, but based on the discussions with the community, what recommendations can be made to enhance the community's resilience to seasonal changes in water availability. So once the research questions are formulated, we then consciously ask the question, what knowledge is required to address this issue? So where we would typically automatically bring our scientific knowledge to it, and in fact we might, from a scientific perspective, already think we know how to solve that problem. Very important is to slow down and to say, well, what other knowledge is also important? So even though we might have an idea of how to solve it from a scientific perspective, we also need to know what is appropriate from the point of view of the stakeholders. So we need stakeholder knowledge, we need knowledge around their values, we need knowledge around, from, as I mentioned, the scientific discipline, also around techniques, technological knowledge. So for each research question, we deliberately ask the question, what knowledge is required to address this issue? And then we get people with that knowledge around the table to discuss and to then go and investigate the issue at hand. So the next stage is the development of the intervention options. So this is the transformational knowledge. What are we going to do? What kind of actions are going to be tested in the case study? And from a transdisciplinary perspective, it is important that these actions cover a whole range of both tangible and intangible aspects. So, for example, if there's a technology that is being proposed, it is important that we look at that technology in all its dimensions in terms of the system. So, look at the financial implications, look at the technological implications, look at the environmental implications, ecological. Does that technology have certain ecological impacts? What are the implications for capacity building? Does the community have the understanding that is required for the maintenance of that technology? Are there certain cultural values or traditions that will influence the effectiveness of that technology? Are there power relations that will influence the effectiveness of the technology? So it's really looking at it from a systemic point of view, bringing all the different disciplines together, not merely saying this is the technology we propose, this is what we're going to test, but to rather really look at that technology in all these different from all these different disciplinary perspectives, or all these different system perspectives. So in our causal loop diagram, the different technologies or elements may, for example, be linked to perhaps that's a bad example, but if we look at introducing a particular technology in a system, we have to look at, well, what are the other important linkages within the system that we need to consider? So technology can impact government, it can impact the community, it can impact the environment, it can impact the social structures within that system. So all of those then need to be looked at. So that's just one example with technology. Say you're doing something like implementing a capacity building program. Even that can have influence on power relations. It can have an influence on social structures. And of course, financial mechanisms there are important. And the sustainability of the capacity building program is important. So it's trying to look at each of these strategies for implementation in a multidimensional way. We then get on to the last two stages, which is monitoring and review, and then communication of the lessons learned. Now, again, with monitoring and review, we go back to the many disciplines that are required, but not only disciplines, the many knowledge types that are required. So if we first look at the disciplines, when monitoring any intervention, we should monitor social, ecological, and economic criteria. It's not just whether this intervention is economically efficient or financially efficient, or whether, for example, if it is to treat water, whether the water then came to the right quality. It's also monitoring, does the community like this intervention? Maybe it improved the water quality, but it resulted in certain dynamics within the community that were not favorable. So it is making sure that the monitoring criteria address all three of those spheres. But in transdisciplinary research, we go beyond that, beyond the multidisciplinary, to include the views and perceptions of stakeholders. So it also may require interviews with users on how effective it was, how appropriate it was for their situation. Often we can develop interventions that are definitely efficient, that may be effective, but may not be appropriate from the perspective of the community, for whatever reason. Then lastly, communication. Because there are many stakeholders involved in the transdisciplinary research, it is important that the outcome of this research is communicated in a variety of ways that are suitable to the different users. So for example, guideline documents, manuals, technical manuals might be produced for practitioners, while research papers, journal articles, PhDs would be appropriate in the scientific environment. And then for society, short policy briefs, information sheets that are accessible might be useful. So we need to think through the different ways in which the research needs to be communicated in transdisciplinary processes. So thank you for listening. There in front of you, you see one of the natural wonders of the world, Table Mountain. And I'm sitting in Stellenbosch, about half an hour away, on a very beautiful day. And I wish you all the best for the rest of the course.